On some worlds, the weather forecast includes diamonds. Not a metaphor, not science fiction, but an actual predicted weather pattern, falling continuously through the interior of planets that exist right now, some of them in our own solar system, and thousands more scattered across the galaxy. Scientists don't just suspect this anymore, they know roughly where to look. The story starts close to home, with Neptune and Uranus, the two ice giants sitting at the outer edge of our solar system. Despite their name, these planets are not covered in ordinary ice. Their deep atmospheres are a thick, crushing mixture of hydrogen, helium, and methane. And it's that methane, a simple molecule made of carbon and hydrogen, that holds the secret. Deep inside these planets, pressure and temperature climb to levels almost impossible to picture, thousands of times the pressure at Earth's surface, combined with temperatures reaching several thousand degrees. Under those extreme conditions, methane molecules don't just sit quietly, they break apart entirely. The hydrogen and carbon separate, and the freed carbon atoms, crushed together under that unimaginable pressure, snap into the same tightly bonded crystal structure that makes a diamond on Earth. Those crystals, denser than the material surrounding them, sink slowly downward through the planet's interior, falling for potentially thousands of miles in a process astronomers genuinely call diamond rain. For decades, this remained an educated hypothesis, since no spacecraft has ever been built that could survive the pressure needed to confirm it directly. So scientists brought the pressure to a laboratory instead. Using tools called diamond anvil cells, combined with extremely powerful lasers and X-ray beams, researchers have repeatedly recreated the crushing conditions found deep inside Neptune and Uranus, compressing carbon-rich materials and watching in real time as diamonds form. The most significant update to this story came from an international research team using the European XFEL X-ray laser, who discovered that diamond formation actually begins at lower pressure and temperature than earlier models predicted. That might sound like a small technical detail, but it means diamond rain likely starts much closer to the surface than scientists previously believed, at depths that could meaningfully influence how these planets generate their bizarre, tilted, and strangely offset magnetic fields, unlike the clean, simple magnetic field surrounding Earth. But the most striking part of this story is how far it extends beyond our own solar system. In follow-up research, the same team modeled how common these exact conditions might be across the thousands of confirmed exoplanets discovered so far. The results were staggering. Of roughly 5,600 confirmed exoplanets at the time of the study, researchers estimated that more than 1/900 of them, an enormous fraction of everything we've discovered orbiting other stars, could plausibly be experiencing diamond rain right now, in worlds smaller than Neptune, a newly recognized category scientists call mini-Neptunes, common throughout the galaxy even though nothing quite like them exists in our own solar system. There's an even stranger cousin to this story. Beyond gas giants entirely, some rocky exoplanets, including one called 55 Cancri e, orbiting so close to its star that its surface may be an ocean of molten rock, have been theorized to contain carbon-rich interiors capable of producing diamonds directly within their mantle, dragged upward not by rainfall, but by violent volcanic activity, embedding crystallized carbon throughout a world utterly unlike anything in our own neighborhood. Put all of that together, and the picture becomes almost impossible to fully process. Somewhere close to a third of every confirmed planet beyond our solar system may be quietly producing one of the rarest and most valuable materials on Earth, not as a geological rarity, but as an ordinary, continuous, everyday weather event, falling for thousands of miles through crushing darkness on worlds no human being has ever seen up close, and most likely never will. What do you think? If we ever found a way to reach one of these planets, would the diamond rain be worth more as a scientific discovery or as literal treasure? Let me know in the comments. Subscribe because next time we are covering HD 199733b, a planet where the wind blows sideways at thousands of miles an hour, carrying rain made of molten glass.